This is Module 7. We're going to be talking about irrational numbers. Now for this module, we will not be using a calculator. So unless you get in a calculator as some sort of accommodation, then you need to learn how to do this without a calculator. This first lesson, what we're going to do is estimate square roots obtained using Pythagorean theorem. Now, we're going to be dealing with this NSA 2 standard, where we use rational approximations of irrational numbers to compare the size of irrational numbers like square roots that are not perfect squares. Okay, we're going to locate them on a number line and we're going to estimate their value. Okay, we're going to use the square root and cube root symbols to represent solutions to equations. We're going to evaluate square roots of small perfect squares and cube roots of small perfect squares, and we're going to know that the square root of 2 is irrational. The other standard right now that we're about to use is our Pythagorean theorem. We're going to use Pythagorean theorem to find side lengths in right triangles. So, for this particular lesson, we intend to find the approximate value for side lengths of right triangles. This is all in Eureka Module 7, Lesson 1. Before we get to that, we're going to start out by estimating some square roots. Now, let's actually start by looking at what a square root is and what a square root is. Whenever I square a number, like 0 squared, that's equal to 0 times 0, right? Which is 0. The opposite of squaring a number is to take its square root. So the square root of 0 is 0, right? Because 0 times 0 is 0. 1 squared is equal to 1 times 1, which is 1. Well, the square root of 1 is 1, right? 2 squared is 2 times 2, which is 4. So the square root of 4 is 2. Look, where's the square root of 2 and square root of 3? They're not shown there, are they? Because those are not perfect squares. We're just doing perfect squares right now. All of these are perfect squares. For instance, 3 squared, which is 3 times 3, is 9. So the square root of 9 is 3. 4 squared, which is 4 times 4, is 16. Square root of 16 is 4. 5 squared, which is 5 times 5, equals 25. So your square root of 25 is 5. 6 squared is 6 times 6, which is 36. So your positive square root of 36 is 6. 7 squared, which is 7 times 7, is 49. So your positive square root of 49 is 7. 8 squared is 8 times 8, which is 64. Your positive square root of 64 is 8. 9 squared is 9 times 9, which is 81. So your positive square root of 81 is 9. 10 squared is 10 times 10, which is 100. Positive square root of 100 is 10. 11 squared is 11 times 11, which is 121. And the positive square root of 121 is 11. 12 squared is 12 times 12, which is 144. The positive square root of 144 is 12. 13 squared is 13 times 13, which is 169. And the positive square root of 169, is 13. 15 squared is, I left out 14, see? 15 squared is 15 times 15, which is 225, and the positive square root of that would be 15. I put all these here because you're going to really need to know all of your perfect squares. These are all called perfect squares because you can take a whole number or an integer and square it, and this is what you're going to get, okay? You're going to get a number. Now, I mentioned up here when I was doing this, I said, okay, we had the square root of 0, the square root of 1, the square root of 4. So we skipped square root of 2 and 3, didn't we? Between the square root of 4 and square root of 9, which is 2 and 3, we had the square root of 5, 6, 7, and 8, don't we? We skipped those. That's because if you look at a number line and you set it up on a number line and you talk about the value of these numbers, when you have square roots that are not square roots of perfect squares, they're going to fit between these integers on a number line. Square root of 0 is 0, okay? So you wouldn't have any square roots of integers in here, but square root of 1 is 1. The square root of 4 is 2, so the square root of 2 and the square root of 3 have to fit in here in between 1 and 2, don't they? Yeah, it's going to be 1 point something. That would be 1 point something. Okay, so if the square root of 4 is 2, the square root of 9 is 3, then the square root of 4, 5, 6, 5, 6, 7, and 8 have to fit between the square root of 4 and 9, don't they? These would all be 2 point something, right? Because they're between 2 and 3. Same here, if you've got the square root of 9, which is 3, and the square root of 16, which is 4, the square root of 10, 11, 12, 13, 14, and 15 would have to fit in between 3 and 4. In other words, square root of 10 would be 3 point something. Whatever it is, it's 3 point something. It's going to be smaller than the square root of 11, 12, 13, 14, 15, right? Okay, this is what this is showing you. So let's start out by finding the estimate. Let's figure out where we would put these on a square root on this number line. If I have the square root of 71, let's look at it. Square root of 71, let's figure out where it might be on a number line. Square root of 71. Well, what we need to do is we need to figure out what two perfect squares is between, because it's not a perfect square. Can I think of anything that's bigger than 71 that would be a perfect square? Let's see, you got 71, 72, no, that's not a perfect square. 73, no. 74, no. 75, no. 76, no. 77, no. 78, no. 79, no. 80, no. How about 81? Yeah, the square root, positive square root of 81 would be 9, wouldn't it? Okay? So we got a perfect square here. Now what, obviously that means this is going to be 8 here. This is going to have to be the square root of 64. This is between those two, right? So it's between 8 and 9 on the number line. Between 8 and 9 on the number line is where the square root of 71 would go. It's going to be 8 point something. It's not 9 because you haven't gotten to 9 yet. It's 8 point something. Let's try 33, the square root of 33. Okay, now let's think about the next perfect square from 33. 34, no. 35, no. 36, oh yeah, because that is 6 squared, right? Okay, so that's got to be between 5 and 6, because 5 squared is 25. The square root of 25 is 5. So this is going to be between 5 and 6. The value for the square root of 33 will be between 5 and 6. It's going to be 5 point something. See, it won't be 6 because it's not 6 yet. It's 5 point something. Now let's look at the square root of 5. Okay, square root of 5. If we're looking at the square root of 5, we know that it's got to be between the perfect squares. So we know the square root of 9 is a perfect square. That would be 3. Be between 2 and 3 because the square root of 4 is 2, right? So it would be between 2 and 3. The square root of 5 would be between 2 and 3, okay? Now let's look at another one, the square root of 50. Okay, square root of 50. Now, if we've got the square root of 50, we're trying to find the two perfect squares on either side, so we'll know what two numbers this is between. Well, let's think. 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. No. Let's see. 61, 62, 63. 64, right? The square root of 64 is 8. And if you're using 7 here, that would be the square root of 49. So see, the square root of 50 is going to be between the integers 7 and 8. Square root of 50 would fit right here on the number line. And then let's do the square root of 14. Okay? We need to find the perfect squares on either side of this. Well, let's think about this. The next one here would be the square root of 25, wouldn't it? That's 5. Nope, it wouldn't be that, would it? No. How about the square root of 16? That's what it would be, because that would be 4. And then this here would be the square root of 9, which is 3. So the square root of 14 is between 3 and 4. Now let's look and see what we've got here. Square root of 5, square root of 14, square root of 33, square root of 50, square root of 71. Okay, they're going up as you see. This tells you what numbers they are between, what integers they are between. Now let's start in the workbook. Let's use Pythagorean Theorem, and we are going to use our square roots here. We're going to estimate about the size of some of these values. Write an equation that allows you to determine the length of the unknown side of the right triangle. We're going to actually solve it without a calculator even. Remember, we've talked about Pythagorean theorem. Pythagorean theorem lets you find the side length in a right triangle. You use the equation a squared plus b squared is equal to c squared, where c is always across from the right angle. A and B, it doesn't matter what sides they are. C, it does. It's across from the right angle. It's the hypotenuse. So let's put this here. A squared plus b squared is equal to c squared. Here's our c because it's across from the right angle. It's the hypotenuse. Doesn't matter here which one's A and B. Okay, my A is 5. My B, I do not have. My C is 13. 5 squared is 25, plus your B squared is equal to 13 squared is 169. Okay? Let's subtract 25 from each side. And that would give me B squared is equal to 9 minus 5 is 4. 6 minus 2 is 4. 144. Okay, when we were doing perfect squares earlier, we learned that 144 is the perfect square for what? 12. When you got this, you're getting rid of the squared. You need just the b. b is equal to 12. Your positive square root there is 12. Would this make sense? Yes, because our hypotenuse has got to be the longest side, and it's 13. This one's 12, that's 5. That could make sense, right? Okay, let's go to example 2. Now I'm going to start trying to show you how to figure out kind of where you are, okay? Let's use Pythagorean theorem on this one to find our side length, because we've got a right triangle here. And this is C because it's across from the right angle. It's a hypotenuse. Okay, it doesn't matter which one's A or B. 4 squared plus 9 squared is equal to C squared. 4 squared is 16 plus 9 squared is 81 is C squared. Let's add 81 and 16. And you get 97. So 97 is equal to C squared. So the actual value for this C is going to be the square root of 97, right? Okay, but let's see if we can see this in a way, an approximation, all right? Let's figure out what two integers that would be between. Well, if we're talking about the square root of 97, the next perfect square up, wouldn't that be 100? So the square root of 100 is 10. And so here's 9. It would be the square root of 81. So we know this is going to be 9 point something because it hasn't gotten to 10 yet, right? It's going to be between 9 and 10. So let's figure out where it is. We're going to estimate it this way, guys. There's kind of a way to estimate it. We're going to set up a fraction. We're going to say it is 9, and let's figure out kind of what fraction. Let's find the distance between the small number and the one we're actually looking for, and this whole range here, okay? 97 minus 81 would give me 16. So this small thing here is 16. Let's see what the long one is. 100 minus 81. Okay, I'm going to borrow one here. Okay, so I got 9. Gives me 10 minus 1 is 9. 9 minus 8 is 1. So this is 19. This is 9 and 16, 19. See, part of the way from here, from the small number to where you want to be is 16, and the whole range is 19. That looks like that's going to be a good bit more than half, doesn't it? It's going to be more than 9.5. So let's figure this out. See, this is approximately 9 and 16 19ths. Well, how do we convert a fraction to a decimal? We divide. The number on the bottom always gets left out of the house when we divide, so we put it on the outside. 19 can't go into 16, but if I put a decimal there, 19 can go into 160. In fact, let's round. About how many times would 20 go into 160? That'd be about 8 times. 9 times 8 is 72. 8 times 1 is 8 plus 7 is 15. That leaves me just 8 left over. So I can replace this 16/19 with 0.8. Okay, we didn't finish it out, but we know this is about 9.8. Okay, so approximate value would be 9.8. Okay, we basically just found a fraction to represent what was behind the 9, and then we divided so we could find the decimal. Let's do another one. This is the next one in the book. Let's see, this is on page. This is on page 2. You're on page 2. That first batch was on page 1. Now we're on page 2. Let's try to find the side here. We know when we're doing Pythagorean theorem that the hypotenuse is across from the right angle. There's our C. We're using a squared plus b squared is equal to c squared. It doesn't matter which one's a and which one's b here. 8 squared plus 3 squared is equal to c squared. 8 squared is 64. 3 squared is 9. That gives me c squared. 64 plus 9 is 73. So 73 is c squared. We're not looking for c squared. We're looking for c. So we find the square root on each side. Your c is equal to the square root of 73. Okay, we need something a little better than that so we can get an approximate value. What two integers could this be between? What two whole numbers could it be between? Okay, so let's look at this. If I've got the square root of 73, let's think what perfect squares we've got that would be above this and below this. Well, let's see, 64 is a perfect square, and that's 8. 9 would be 81, wouldn't it? Okay, yeah, 73 fits between 64 and 81. So we're talking about something that's 8 point something, okay? We need to figure out the fraction, okay? About, or it's going to be between 8 and 9. Let's figure out how far between 8 and 9. Let's set up a fraction. Okay, let's find the distance between 64 and 73. 73 minus 64 would give me 9. Then let's find the whole value, whole length here between 64 and 81. 81 minus 64. Got to borrow 1. I've got 11 minus 4 is 7. 7 minus 6 is 1. 17. So we're talking about 9/17, okay? This would be about, we'd start with 8 because we're not at 9 yet, about 8 and 9/17. Well, let's think about 9/17. That would be about half of it, wouldn't it? Well, let's try that and see. Let's convert our 9/17 into a decimal. We're dividing 9 by 17. When 17 is on the bottom, it gets left out of the house. It can't go into 9, but if you put a decimal there, how many times can 17 go into 9? Okay, let's try 5 and see if it works. 7 times 5 is 35. 5 times 1 is 5, 6, 7, 8. Yeah, that works, right? Because we only have 5 left over. It's less than 17. So this is about 0.5. Our 9/17 is about 0.5. So that is about 8.5, right? Now, we're not going to do 4. We're going to look at the bottom of the page where it says exercises number 1. Let's do the same thing here. We're trying to find this side length, right? We know that our C is across from the right angle. A squared plus B squared is equal to C squared, all right? My C is 11, so I could say 6 squared plus B squared is equal to 11 squared. C squared is 36, plus B squared is equal to 121. Okay, to get the b squared by itself, I need to subtract 36 from each side, right? Gives me b squared is equal to, okay, I'm going to have to borrow one here, so this gives me 11, and that's 11. 11 minus 6 is 5, 11 minus 3 is 8, okay? So we're talking about b squared is equal to the square root of 85. We take the square root of this. This side should be about the square root of 85. Let's see what that would be between. What two integers that would be between. We need to find the perfect squares that would be on either side of this. Well, we know that 81 could go here, because that's 9, and 100 could go here, that's 10. Okay, so the square root of 85 fits between square root of 81 and square root of 100. So we're talking about 9 point something. So our answer is between 9 and 10. Okay, let's see what fraction it is. The difference here is 4. The difference here is 19. So we're talking about 9 and 4/19. Let's decide what 4/19 is. Let's divide 4 by 19. So we're going to have to put a decimal here. How many times from 19 going to 40? Think about it, that is 20. How many times from 20 going to 40? Okay, about 2. So 9 times 2 is 18. Carry 1. That's 2. That's 38. And I only have 2 left over. So what we're talking about is about 9.2. Okay. Now, check the next page, page 3. And let's try this one. When we're using Pythagorean theorem, here's our c because it's across on the right angle. It's the hypotenuse. So we're using a squared plus b squared is equal to c squared. We've got 6 squared plus 10 squared is equal to c squared. 6 squared is 36. 10 squared is 100. That's equal to c squared. So I've got 136 is equal to c squared. I'm not looking for c squared. I'm looking for the c, so I have to take the square root of each side. C is equal to the square root of 136. Okay, I need to find something that makes more sense than just simply the square root of 136. Well, let's see what perfect squares it's between so we can figure out what two integers it's between. 144 is a little bigger than that, so that would be 12. And the square root of 121 would be 11. So it's between 11 and 12. And that makes sense because it's got to be bigger than 10. It's the hypotenuse. So let's figure out what fractions it is between these two. Let's subtract these two, 136 minus 121. And I wind up with 15. And the whole distance here is 144 minus 121, which would give me 23. So we're talking about, let's see, 11, about 11 and 15/23, right? Okay, 15/23. Let's divide 15 by 23. So that's about 150. You have to put your decimal there. How many times would that go in there? Well, let's look and see. How many times would 25 go into 150? Let's see if it's about 6. 6 times 3 is 18. 2 times 6 is 12, and 1 is 13. Okay. If I do that, I borrow one here. That's 10 minus 8, which is 2. 4 minus 3, which is 1. So it's 12, 20. Yes. So it's about 6. Okay. So we're talking about 11.6. Okay. And let's go to the bottom of this and let's do this one. We're looking for this side. Your C is across from your right angle. This could be our A or B. It doesn't matter. This could be A squared plus 9 squared is equal to 11 squared. That's A squared plus 81 is equal to 121. We got to go across the equal sign, so we subtract 81 from each side. And your a squared would be equal to 40. Okay, we need to take the square root of that. A is equal to the square root of 40. But we need a more reasonable estimate of that, something that looks more like an integer, right? So let's figure out what two numbers it would be between. Our answer is going to be between, well, let's see, the square root of 36 is 6, and 7 would be the square root of 49. So see, it would fit between those two. So it's between 6 and 7. So that means it's 6 point something. The distance between these two is 4. The distance between those two would be, what, 13? Because 40 minus 36 is 4. And 49 minus 36 would give me 13. So we're talking 4/13. That means we need to divide 4 by 13. How many times will 13 go into 4? It won't. Put a decimal there. How many times will it go into 40? Well, it can't be 4, so let's try 3. 3 times 3 is 9. 3 times 1 is 3. Okay, that's 0.3. So this is going to be about 6.3. Okay, simple enough. Now let's look at, it shows you right here how to handle your perfect squares. It says when you're dealing with the number 58, it's not a perfect square, but it's between the squares of 49 and 64 here. And it shows you how to get there. Let's go to the problem sets. The problem set is actually on in your workbook on page 11. Okay. Use Pythagorean theorem to estimate the length of the unknown side of the right triangle. So we're going to call this A because C is right here. And we know we start with our Pythagorean theorem. A squared plus B squared is equal to C squared. We don't have A, but we have B, which is 13. And our C is 15. Okay? A squared plus 169 is equal to 225. Okay, we're solving for A squared, so let's subtract 169 from both sides. And A squared would be equal to, okay, we're going to have to borrow 1 here. 15 minus 9 gives us 6. Okay, we've got 1 here. Got to borrow 1 there. So that gives me 11 minus 6 is 5. Okay, so I've got the square root of 56. Now, let's get an approximation of this. Let's see what square 56 is between. We know probably the next perfect square would be 64, which is 8. And the smaller one would be 49, which is 7. So the answer is between 7 and 8, which makes sense because this could be about 7 something, right, if the hypotenuse is 15. And let's figure out what it is. Let's find the fraction. If I subtract 56 minus 49, that would give me 7. And 64 minus 49, 64 minus 50 would be, let's just do this. That's 14 minus 9 is 5. 5 minus 4 is 1, so that would be 15, okay? So we're talking 7/15, right? Okay, 7/15, that would be just a little bit less than 1/2. So let's try doing this. 15, we're going to divide 7 by 15. And let's think about this. 15, 30, 45, 60, 75. So it's got to be 0.4. 5 times 4 is 20. That's 4, 5, 6. Yep. So it's about 0.4. It's between 7 and 8, so it'd be about 7.4. And you see there's more of this to than more than half of that, so you may be closer to 7.5, but it's 7.4, okay, is about what you've got. And that makes sense. And since your hypotenuse is 15. All right. And then the next one, number 2. Okay, let's find the estimate of this side here. We know that this is our C, so this could be A or B. It doesn't matter. We're using Pythagorean theorem. A squared plus B squared is equal to C squared. I don't have an A right now. I'm calling my 12 B. My C is 13. So A squared plus 144 equals 169. Let's subtract 144 from both sides. And my A squared would be equal to 25. Let's take the square root of that, and A would be equal to 5, okay? So we don't have to go through anything else. We've got that one, don't we? Let's try this one. We know this is our C because it's across from the right angle. It's the hypotenuse. A squared plus B squared is equal to C squared. My A is the 4. We can call A the 4 and the B the 12, or you could do the other way around. Your 12 could have been the A. Okay, but we know our C is the one we don't have. 4 squared is 16. 12 squared is 144. This equals C squared. Add these two, and I get, let's see, 144 plus 16. That's 160. 160 is equal to C squared. Let's take the square root of both sides, and C then would be equal to the square root of 160. Okay, that's not a perfect square. So we're going to need to figure out where it is. We know that square root of 144 is 12. And we know that 13, if you square it, it's 169. So this is going to fit between 12 and 13. Your answer is between 12 and 13. Okay, well, that could work because, see, this is 12. That could be 12 point something. Let's figure out what it is. Let's find the fraction. So 160 minus 144. Borrow 1 here. You've got 10 minus 4 is 6. 5 minus 4 is 1. So that's 16 over, and let's find the distance here. 169 minus 144. 9 minus 4 is 5. 6 minus 4 is 2. That's 25. 16 over 25. Okay, so that's going to be more than half, isn't it? Let's look at it and see. I'm dividing 16 by 25, or 160, as it would be, because you're going to have to put a decimal here, put a 0. 25, 50, 75, 100, 125 would be 6. So let's do that. 6 times 5 is 30. 2 times 6 is 12. 13, 14, 15. Only have 10 left over, so it's 0.6. This is about 12.6, okay? It's what we're looking at. Make sense? That means approximately, that little squiggly line. Let's look at number 4 here. Number 4 is actually on page 12. All right. We're looking for this side. We know that the C is across from the right angle. Pythagorean theorem is A squared plus B squared is equal to C squared. So if I got A squared plus 11 squared is equal to 13 squared. A squared plus 121 is equal to 169. Okay. So let's subtract 121 from both sides. And I get A squared is equal to 9 minus 1 is 8. 6 minus 2 is 4. A squared is equal to 48. So we take the square root on both sides. So we need to figure out what two numbers the square root of 48 would be between. We know the square root of 49 is 7. And the square root of 36 is 6. So it's going to be between 6 and 7. Okay, let's see about what it is. Let's get an approximation. All right. Let's find the fraction here. If I say 48 minus 36, I get 12. Okay, so my fraction would be 12 over 49 minus 36, the whole distance between the squares of those two. 9 minus 6 is 3. 4 minus 3 is 1. Okay, so we're talking 12/13ths, right? I would be dividing 12 by 13. Okay, Let's see if that could be a 9. Let's just try a 9. 9 times 3 is 27. It's 9, 10, 11. Yep, there we go. That would give me 3. 120 minus 117 is 3. So what we're talking about, it's about 6.9. See, it can't be 7 because it's not at 7 yet. It's about 6.9. Does that make sense? Yes, it's less than the hypotenuse, which is 13. Okay, let's go to number 5, which is on page 12. This is the hypotenuse. It's across from the right angle. A squared plus b squared is equal to c squared. Okay, doesn't matter which one's a and which one's b. 6 squared plus 8 squared is equal to c squared. 6 squared is 36. 8 squared is 64. That gives me c squared. 100 is equal to c squared. And the square root of 100 is actually 10. I don't need to go any farther, do I? It gave it to me as a perfect thing, because 100 is a perfect square. Okay, let's find the length of this side. We know it's the hypotenuse. It's across from the right angle. Pythagorean theorem is a squared plus b squared is equal to c squared. 4 squared plus 7 squared, or you could say 7 squared plus 4 squared, doesn't matter. Your c is the one thing that has to be in the right place. That's 16 plus 49 is equal to c squared. Okay, 49 plus 16. 9 and 6 is 15. 4, 5, 6, 65. Okay, is equal to c squared. Now we need to take the square root of this. We need to figure out square root of 65. Well, we know the square root of 64 is 8. Square root of 81 is 9. So this would be between 8 and 9. Okay, this is only 1. This is 81 minus 64. Borrow 1, 11 minus 4 is 7, 7 minus 1 is, okay, so we're talking 1/17. So this is going to be very small, isn't it? It's going to be 8 point something. We've got 1/17. So you would say 17, oops, 17 goes into 1. It can't go into 1. Can't go into 10, can it? Okay, so we got a 0 here. You got to put it into 100. So let's think about this. What if it's about 20 into 100? Let's see if 5 will do it. 7 and 5 is 35. That's 5, 6, 7, 8. Okay, that's 85. Yep. 0.05. So that if you round that, it's 0.1. So this would be about 8.1 or 8.05, right? 8.1. So we're going to round it to the nearest tenth. Let's look at number 7. Number 7 is at the top of page 13 in your workbook. Okay, I'm looking for this side. This is my hypotenuse because it's across from the right angle. Doesn't matter if I call that A or B. We know Pythagorean theorem is a squared plus b squared is equal to c squared. Okay, we don't have A, but we do have B, and our C is 12. Okay, that's a squared plus 9 is equal to 144. Let's subtract 9 from both sides. And that means a squared is equal to 135. Let's take the square root of both sides. See, we know this is the square root of 135, but we don't know what the square root of 135 is, okay? Got to figure out what it's between. Well, we know that the square root of 12 is 144, right? We know that the square root of 11, or the square root of 121 is 11, right? So it's going to be between 11 and 12. And that makes sense because your hypotenuse is 12, so it can't be 12. All right, so let's find the distance here. The difference between those two, 135 minus 121 is 14. And 144 minus 121 would give me 23. So we're talking about 14 23rds. So we're going to divide, not 14 over 23. We're going to divide 14 by 23. Okay. Can't go into there. We got to have a decimal. How many times will 23 go into 14? Let's try 7. 7 times 3 is 21. That's 14, 15, 16. No, that's too much, okay? Let's try 6 instead, all right? 6 times 3 is 18. Carry a 1. 2 times 6 is 12. That would be 13. So that's 2.6, okay? That would be about 11.6. The triangle below is an isosceles triangle. Use what you know about Pythagorean theorem to determine the approximate length of the base. Well, if I can get this length here, it's the same as this. So if I get that, I multiply it by 2. I'm dealing with Pythagorean theorem. Okay, I need to find this side. All right? A squared plus B squared is equal to C squared. A squared plus 7 squared is equal to 9 squared. A squared plus 49 is equal to 81. Okay, let's subtract 49 from 81. That would give me 32. Okay. A squared would be equal to 32. So we're talking about the square root of 32. All right. Let's see if we can figure out what the square root of 32 is. All right. Square root of 32. It's going to be between the square root of 36, which is 6, and the square root of 25, which is 5. So it's going to be between 5 and 6. Let's see what fraction it is. If I say 32 minus 25, I've got 7. 36 minus 25, I've got 11. So we're talking about 7 11ths. Okay, let's divide 7 by 11. All right. Okay, it won't be 6. It would be, it won't be 7, it'd be 6. 6 times 11 is 66, which gives you 4 left over. So we're talking about 5.6, okay? Now remember, if this one's 5.6, they're asking for the base. They're asking for this whole thing. So you'd add 5.6 plus 5.6, and you would get, let's see, that's 12, 10, that's 11.2, okay? And then the last one, give an estimate for the area of the triangle shown below. Okay, area is equal to 1/2 the base times the height. Well, here would be the base, and there would be the height. So I need to find something to find this base, don't I? Pythagorean theorem would get me there. A squared plus B squared is equal to C squared. That's 3 squared plus B squared is equal to 7 squared. 9 plus B squared is equal to 49. Let's subtract 9 from each side. B squared is 40. Let's take the square root of each side, and your B becomes whatever the square root of 40 is. So let's see where that would be. That would be your square root of 36, which is 6, and your square root of 49, which is 7. You're between 6 and 7. Okay, so B is between 6 and 7. Okay, let's figure out where it actually is. This is 4. This is 13. 4/13, okay? I'm going to divide 4 by 13. Okay, that would be 3, which is 39. That leaves me 1 left over, so 0.3. We're talking about 6.3. So this base is 6.3, about 6.3. Your area is equal to 1/2 times 6.3 times your height, which is 3. Okay, let's do 6.3 times 3. 3 times 3 is 9. 6 times 3 is 18. 18.9. 1/2 of 18.9. which would give me, let's see, 9.45 or about 9.5. Okay, centimeters. Okay, that covers all the questions for this particular section. We have used Pythagorean theorem to find the side lengths in right triangles, and we have estimated the values from the square roots, okay, without using a calculator.